So in this video we're going to look at system security and specifically the threats to different networks and computer systems. In the next video we'll look at identification and prevention of these different threats. There are a number of reasons why systems might be attacked. Firstly, they might just simply be for fun. So a couple of years ago there used to be a group called LulzSec, and they would go around targeting companies and organisations, basically seeing if they could hack into them, cause them some havoc just for the fun of it, and people would readily join in with that. You've got financial gain, to be able to make money from the different attacks that might take place. You've got personal attacks, so maybe going out and blackmailing someone might be the end goal of the attack. Industrial espionage, essentially companies spying on other companies, trying to get ahead of them in the marketplace. They might try and steal trade secrets. They might be trying to find out what other companies are working on and so on. You just got general disruption, causing services to no longer be online, like the PSN on Xbox Live hack several Christmases ago. Being able to take information and data. Data now is particularly valuable. And finally, we've got rewards. So a different sort of hacker might be asked by a company to have a look at their systems, find all the weaknesses in them, actually go ahead and try and hack themselves, and then they could get paid for it. Now, before we look at the specific threats to networks and computers, there's a couple of different types. So we've got active attacks. An active attack is where a network is attacked with malware or some sort of other planned attack. Often leaves behind evidence, so it might delete a file, it might edit some different files, it interacts with the computers in a way that's quite detectable, so it could leave a log as well on the network. There's also passive attacks. A passive attack is incredibly difficult to detect. Essentially what happens is that the attacker will try and monitor the data travelling across the network. So if you see in this diagram on here, Bob is trying to send a message to Alice, and an agent is watching what's happening on the network and can read the data that's passing between both of them. The first threat we're going to look at is malware. Malware is quite a common threat to computers and networks, short for malicious software, so sort of cut those words in part and sort of join them together. There's a couple of different types of malware. I'm going to have a look at some of these different types. So the first and most commonly spoke about one is viruses. The whole idea behind them is they work much like a biological virus. They duplicate, they attach themselves to files, and the users spread them by copying files and activating them. So in this diagram here, user finds a program on the internet that doesn't realise is a virus. Someone's put that on a web server, and it's now on that other person's computer when he activates it. Now, the important thing to remember here is that viruses require user input to spread. They don't spread automatically. Someone has to open them, someone has to send them. So it's really important for a virus to stay well hidden until it's been spread further. Otherwise, someone would catch it, figure out, and it would not get spread any further. Our next type of malware, we've got worms. Like viruses, but they self-replicate without the help of a user. So an attacker can get a worm onto a network, and it can actually work its way around the different computers without having to be sent, without having to be copied onto some sort of USB drive or emailed anywhere. They can sort of move around by themselves. So if you look at the diagram, it can spread between the different computers and the servers on the network with relative ease. We have Trojan horses, so named after the mythological Trojan horse, where Greeks waged war against the independent city of Troy. They offered a large wooden horse as a gift. Now, once inside the city walls, soldiers burst out and started attacking those who lived in the city, and this type of malware works pretty much in the same way. often disguised as perhaps a popular piece of software, popular game, popular relatively expensive program. They get onto the person's computer looking like they're the real thing, and once installed, obviously they're not what they said they were, and can start to cause some damage. Trojan horses don't replicate by themselves, similar to viruses, so it does require someone to sort of do the actions and copy it around, for it cannot spread like a worm. Now, once on our computer system, those different types of malware can do a range of different things. So they could be deleting files, they could be modifying things, they could hold the computer to ransom if you've heard of ransomware, spy on users, altering permissions across computers and different files, and they could open up backdoors to allow other malware to get onto the system more easily. Now, more often than not, malware only does one or two of these different things. It doesn't try to do all of them. The more actions a piece of malware makes, the more likely it is that it's going to get found. Once on a system, malware can be removed with anti-malware software. Often called antivirus software, you will very rarely see it be called anti-malware software. The purpose of this software is simply just to scan a computer for malware and attempt to remove any that it finds. There's different features that antivirus software can give a user. Not all of them have all of these features. Some might pick and choose. So you've got on-demand scanning, where the user can trigger virus scanning, malware scanning on that computer at a time that's convenient for them. We've got active scanning, where the anti-malware software will actively, pretty much all the time, scan that computer for any changes, for any signs of malware. And then we've got spam filtering, so looking at the user's email, trying to find any viruses that might be in there before they can open them themselves. Some software is more specialised, so you'll get some that will specifically look for spyware, and so on. A common misconception is that firewalls sort of work like anti-malware software, where they prevent viruses getting on the system. Now, this is often confused with active scanning, which is just constantly scanning what's happening on the computer, what files are being downloaded, and so on. So don't get confused between a firewall and active scanning on anti-malware software. So on to our next threat, social engineering. Essentially, it's taking the fact that humans are the weak point in most systems security. The very basics of it is tricking people into breaking normal security procedures. So it could be tricking them to hand over a password, to hand over their credit card information, often by getting them to gain trust. So phishing with a PH is probably the most common social engineering method, often using telephone calls, text messages, emails, pretending to be someone else in order to extract some form of sensitive information. Like I said, it could be a password, it could be a PIN code, it could be credit card details in order to get some money out of a person. So as you can see, this is a phishing email. It's meant to look like Netflix, and trying to trick a person into typing in their credit card information again. Now, on that phishing email, you can see loads of different mistakes. It's quite clearly not a real email from Netflix to us, but to someone else who's perhaps just skim reading it, it might be enough just to trick someone. Other forms of social engineering can include farming, shoulder surfing, where, like in the picture, someone simply looks over someone's shoulder and can view the password or PIN that they're typing in. There could be bait and switch scenarios, tailgating, and quid quo pro attacks. Now, on to the next threat, we've got data interception and theft. Now, quite often data can be stolen over a network, but you need to consider the fact that some data is also physically stolen, whether that be on an actual computer that's stolen or on some sort of storage device like a USB drive or portable hard disk. On a network, A man-in-the-middle attack is often used to passively collect data and monitor what's happening. So in the picture you can see a laptop connected to a server, and in the middle there is an agent who is monitoring that data and can probably see what's happening and collect things like credit card information, passwords, and so on. If that agent does start modifying the data that's been sent, it becomes an active attack, because then you're getting evidence that can be used to sort of identify that attack is taking place. Now, more physical methods of data interception include actually physically stealing devices. So someone could be sat in a coffee shop and the laptop or smartphone could be stolen. If the device isn't secured properly with a password or encrypted, that data can be extracted quite easily. Within a company, an employee could be the person stealing that data. So if the USB ports on the computers are not disabled, that data can be taken off easily using a USB drive or a portable hard drive. Now, ways to limit the impact of data interception and theft. The most common method is actually encrypting the data. So scrambling the messages that are being sent. So even if someone does carry out the attack, the data they get is basically useless to them. So it's difficult to perhaps stop these attacks, but you can mitigate the impact of them quite dramatically. In terms of stopping data from being physically stolen, locking doors, making sure that people who shouldn't have access to computers can't access them. Securing devices with passwords, so if they're stolen, the data can't easily be accessed. Again, encrypting data on the hard drive so it can't be accessed if someone gets it who shouldn't have the data or the computers. Locking USB ports so people can't take data off the computers as easily. And you can physically lock devices to objects, so you can get these special locks that hook into the case of a laptop and tether them to a table or tether them to the floor so they can't be taken away. If you think about the servers that we have at school, all of them will be physically drilled or screwed onto a frame, which is then screwed or drilled into the floor, so someone just can't easily take them away. Obviously, someone could take the time to unscrew everything and take a server, but that's more time that someone would have to catch them in the act. While we're looking at different threats that might harm a computer or a computer network, the network policy is a great way of preventing introducing weaknesses to a computer or to a network. And the main part of a network policy would be the acceptable use policy. It's a document that covers a wide range of responsibilities for the users to sort of cover over their weaknesses that they may introduce into the network. So it will cover things such as downloading and installing software that's not approved by the network administrator. So if you think about school, you can't just go on a website and install a program that's not been approved by the network administrator. You've agreed not to do it, and the computers are set up in a particular way by which they won't let you install that software. It'll cover things or accessing particular websites. So at school we've got a list of blocked websites. Similarly, companies will have similar software which will prevent their employees from accessing particular websites. And most of the time this is to prevent people from going on websites that might try and install malware, that might try and collect information or trick users into giving up their credit card information or passwords. The acceptable use policy will also cover things like turning off firewalls and antivirus software, preventing users from doing that, and will also have a section on ensuring that passwords are a particular strength, so it will specify the rules in terms of how long a password should be, what sort of characters should be in there, such as uppercase, numbers, punctuation, in order to help protect the network from different threats. So on to brute force attacks. A brute force attack is where someone attempts to access an account through trial and error. So they'll start off with an email address and then they will attempt passwords until they can get onto the account. Now, more often than not, they'll start with a list of known popular passwords that people are more likely to use before moving on to things like dictionary words and then onto sort of random number letter combinations. An attacker doesn't manually try and type these passwords in. It would take them an incredible long time to try even a 1,000 different password attempts in that login box. So they use software instead which are capable of making thousands of attempts each second. There are some preventative methods that you can use to sort of prevent this sort of attack. So you can have limits on the number of times someone can attempt to log in with an incorrect password. Obviously, it would stop the attacker from doing it, perhaps block their IP address, and it slows down that process massively. But the most important thing that you can do is having a strong password, because not all services, not all websites will implement those sort of other methods of locking particular IP addresses known to be attempting passwords and so on. So making sure your password is hard to guess is incredibly important. So when considering making a password, you need to think about the way that an attacker would try and brute force a password. So if you think about a byte combination lock, they often have 4 digits, and each digit has 10 possible options. So there's 10,000 possible pins. Now, if you apply that to passwords, if you're using a password that only uses lowercase letters, each character in your password has 26 options. Now, if you increase the number of different types of characters you can have in there, such as making sure you've got uppercase, numbers, punctuation, in addition to having more characters in your password, you're significantly increasing how unique that password is and how much time it would take to randomly guess your password. Now, the problem obviously is you can create an incredibly long password, which is incredibly difficult for a computer to guess, but it does become harder to remember. So you've got to get the balance right between how memorable it is and how long that password is in terms of its strength. Because if you're finding that you're changing your password frequently, you're going to change it to a password that's not as strong. This table on here shows you how long an attacker would take to randomly guess a particular password. So if you look down the left hand side, it shows you how many characters a password it would have in, and across the headers on the top it shows you how many different types of characters might be in a password. And obviously the sweet spot is being in that green area where you've got many hundreds of years it would take for your password to be cracked. You want to make it so that the hacker would think that the amount of time and energy taken to crack a particular password would make the data that they would get not worthwhile. Now, you would think that even a year or 12 years would be enough to dissuade someone, but these are figures calculated on current computing power and one computer just working on it. It would take one computer perhaps 12 years to break a 9-character password with uppercase, lowercase, symbols and so on, but it would take 12 computers 1 year to do the same amount of work. And over time, computers become more powerful. They might use specific hardware that's better suited to cracking passwords. So you want to make sure that your password is as strong as possible in order to dissuade them from wanting to break and get access to your accounts. On to the final set of cybersecurity threats, we have denial of service attacks. Denial of service is simply a method of taking down an online server that provides some sort of a service to people. So we're thinking like PlayStation Network, we're thinking Xbox Live, we're thinking Netflix, we're thinking particular websites, social media sites. If you take them down using this method, it's a denial of service attack. It's often done by repeatedly sending requests to the server to the point where genuine requests can't get through. And the way you send these requests is in a way that is difficult for that server to actually process. So they're taking a lot of processing power and a lot of processing time to try and figure out what these requests are, and it essentially stops the service from working. So a couple of years ago, like I may have mentioned before, PlayStation Network went down at Christmas because too many people were maliciously trying to send requests to PlayStation Network, and other people who genuinely needed or wanted to be on couldn't get onto that service. Now, if many computers are doing this, we call it a distributed denial of service. Now, if there's many computers attempting this sort of attack, more often than not, these are computers infected with some sort of malware, and there'll be someone somewhere saying, look, these computers need to attack this service, and it sends out a command, and that's how it works. Perhaps the most complicated cybersecurity threat to get your head around is something called a SQL injection or SQL injection. Now, most websites are database driven now, so the content on there is stored in a database, and all the pretty parts of the page that you see are stored separately from that page content. Essentially, the whole idea behind running it on a database is it makes it easier to manage the pages in the long run. Now, databases are programmed in a language called SQL or SQL. Now, every time you go to a web page, it has to get the contents from the database, join it up with all the pretty pictures, all the HTML that make up the page, and then it sends it to you, the end user. So every time you access a web page, it's having to make an SQL or a SQL request to that database. Now, if you're on a website that's got a form where you can type something in and submit it to the website, most often it will use SQL to store that data in the database. Now, someone performing a SQL injection attack would essentially write a SQL command into those text boxes in the form and submit the form. And if the website has not been set up properly to deal with it, it could actually run that command on the database. So you could write in a command into that text box, submit it to them, and that command could be to start deleting parts of the database. It could be to add a new user account to give them administrator privileges. It could be to inject code into a page that could have a link to a virus. So once you start using these SQL injection attacks, and if they work on a particular website, you can start causing a lot of damage, because you could insert things in there that could affect millions of people who were accessing that website. Now, to prevent a SQL injection, the most common way would be using checks on the website to make sure that's typing in those commands into those boxes and identifying those commands before they get ran on the database, and that's what we call input sanitization. So checking that particular parts of the SQL syntax are contained within that text box. It could also include making sure that if you've got a text box that should only accept numbers, that only numbers can be typed in there. If you're asking for a first name, that maybe you don't let the first name be over 20 characters long, and so on. These are all different ways that you can use to help mitigate this issue. Now, the final threat that you need to be mindful of is an insider attack. Now, an insider is essentially someone who just works for a company. They're inside the company walls, they have access to the computers, perhaps more than someone in the general public, and they could use any of the previous threats that I've talked about to damage a company. Now, a person inside the company is going to be more trusted. They might have a log on already, or they might have physical access to the computer, so they're going to have free range to do a lot more damage than a hacker who is perhaps outside the company on the internet, or someone who is just in a coffee shop on Wi-Fi. So an insider attack could cause a lot more damage, and it could open up the company to significantly more attacks. Now, in the next video, we're going to have a look at identification of attacks, sort of figuring out, how attacks are happening, how we can figure out if they are happening, how do we stop them before they cause any damage, and ways that we can prevent them from perhaps damaging our computer networks as much as they possibly could.